Assalamualaikum warahmatullahi wabarakatuh. In this video, me and my partner will be presenting on a topic about determination of microplastics in food using Raman spectroscopy. Raman is one of the example of spectroscopy technique used in analysis technique. In these cases, microplastics is the analyte that will be observed from the sample. Throughout the video, we will go into the introduction of microplastics, the importance of analyzing the analyte from the sample, the overview of the Raman spectroscopy, the comparison of why Raman is chosen compared with other methods. We will also be looking up on the details in experimental data and spectra that we took from journal. We will discussing about the spectra and give suggestion improvements in the spectrometric technique. Microplastics pollution has become a worldwide concern in aquatic and terrestrial environments. Microplastics could also enter the food chain, causing potential harm to human health. Microplastics are defined as plastics smaller than 5 micrometer, and it is resulting from the breakdown of larger plastic debris and synthetic textiles. Microplastics can vary in size, shape, and material. It can cause negative effects on living organisms, include energy metabolism disorder, oxidative unbalance, and DNA and immunological damage. Microplastics can be exist in the seafood that humans take, in the drinking water, throughout the processed food, and in various kinds of salt. Why it is important to analyze microplastics in food sample? As discussed earlier, microplastics can cause potential health risks to consumers. Therefore, by making their detection and quantification, it is crucial for food safety. Microplastics detection also supports ongoing research to better characterize their sources, fate, and effects in ecosystems. By analyzing microplastics, also can develop mitigation strategies on environmental impact, because as we concern, microplastics can enter the food chain. To facilitate the risk assessment of microplastics in human, it is important to have a reliable analytical technique to detect, quantify, and identify microplastics of various materials, size, and shapes from food matrix. Raman spectroscopy are mostly employed in the examination of microplastics. Raman spectroscopy provides information about the chemical structure of molecules present in microplastics through their spectral fingerprint. Inelastic scattering of light by molecules generate vibrational spectra that are specific to different molecules. How does it work? When monochromatic light from laser interacts with molecules, photons are scattered elastically. This is what we call Rayleigh scattering. But when a small fraction of light is scattered inelastically, it experiences a shift in energy corresponding to vibrational energy levels of the molecules, and this is what we call Raman scattering. This shift provides a molecular fingerprint unique to each substance. This figure shows the instrumentation of Raman spectroscopy and their main components. The main components including laser source, sample cell, wavelength selector, and the detector or transducer. Each of these components have their own functions. Laser is a source that provides the monochromatic light required to induce the Raman effect. Sample cell functions in position the sample for optimal interaction with laser beam. while reference selector disperse the scattered light to measure the intensity of Raman shift, and detector acts to capture the dispersed light and converts it into signal. This signal can be read out to the readout device such as computer and printer. There is another commonly methods to analyze microplastics such as pyrolysis, gas chromatography, mass spectrometry, and Fourier transform infrared spectroscopy. But why is Raman spectroscopy is widely used and recommended to analyze this analyte compared to these other two methods? Let me get look to two of each. Pyrolysis GCMS is not a spectroscopic technique, but it is thermogravimetric analysis where it is using thermal decomposition to analyze chemical composition. The polymer in microplastics will decompose at a high temperature, followed by analysis using GCMS. Although this method is highly sensitive, provides detailed chemical information, and could identify the plastic polymer, they lack the ability to acquire detailed information on size and shape of microplastics. It is also a destructive method and required a long sample preparation. Meanwhile, FTIR is similar like Raman. It is a spectroscopic method. The principle of FTIR is it measures a molecular vibrations based on dipole moment, but Raman based on polarization of the molecules. The problem with FTIR are it will cause water interference while doing the analysis, and it have irregular sample identification challenge. Why choose Raman spectroscopy? Compared with pyrolysis GCMS, Raman is a non-destructive method to the sample, and it also have a high specificity. Raman requires minimal sample preparation, thus shorter time consuming compared to pyrolysis GCMS. The important part about Raman is it can detect even very small particles up to 0.4 micrometers, which favored the analysis of small size of microplastics. Other than that, unlike FTIR, Raman has the advantages of non-interference with water signals.
Now, we will discuss further about the sample preparation for the analysis of microplastic. So, in this, from the journal, the analysis of microplastic is from the fish. Firstly, sample collection is being done. Two important commercial fish species were collected in the sea, and they are stored in freezer at negative 20 degrees Celsius. Next, after the storage or preservation of fish, sample prep for the sample is done by washing with distilled water to remove the contaminant. Next, the digestive tract is dissected and stored at negative 20 Celsius before the extraction of microplastic. For the next step, for the microplastic extraction, the sample are being digested with solution which is potassium hydroxide, and it is filtered by cellulose filter. Before the sample is being seen under microscope, it is need to undergo drying process, and the observation under microscope is being done. After the extraction of the analyte is run to the instrument in this case, we investigate the microplastic using Raman spectroscopy. Before we in the Raman spectroscopy, we need to have several things we need to consider. For the spectra collection, we the this analysis is used confocal Raman microscope, which from horrible scientific France. The wavelength used is 785 nanometer laser, and for the magnification, the research use 100 times objective, and the integration time is 1 second. The Raman spectrum was taken at wave number between 15 and 3500 cm -1. When after running to the Raman, the spectra is compared with the reference data to determine the polymer type of the microplastic. Next, we move on to the interpretation of the spectra. This diagram shows the Raman spectral result of abundant polymer type in fish species, which are two. Firstly, polypropylene, and the second one is polyethylene. We are discussing about the every spectra is done by the research. For the spectrum A, which is polypropylene, the spectrum shows clear distinct peak with high intensity and specific Raman shift value. For in this spectra, it shows a high intensity around 850, 1120, 1200 and 1460 cm -1. So when the intensity is high, it gets strong signal, and which give the accurate result. But there is challenge in this spectra, which there are some background noise visible at lower intensity, which might affect the clarity of minor peak. For the next spectrum is polyethylene. This spectrum also shows the same characteristic from the spectrum A, which show the distinct peak and several Raman shift, which are 430, 850, 1000 and 3900. It indicates the presence of polyethylene. As you can see, the spectrum is sharp, so it considered is high quality spectral data. But the limitation of this spectra is, as we can see, there are so many background noise compared to spectra A, which indicates the less pronounced and might be interfered by fluorescence. Next, we can comment for the Raman spectroscopy in terms of selectivity and specificity. So for the selectivity, the spectra demonstrate the capability of Raman spectroscopy to selectively identify specific polymer type, which in this case polypropylene and polyethylene, because two different types have two different specific fingerprint. So it indicates exhibit characteristic peak between the Raman shift value, which useful to identification. Lastly, both spectra shows high resolution, which we can distinguish microplastic from other particles. For the specificity, the distinct peak observed in both spectra, as you can see the previous slide, which we can confirm this instrument has high specificity to identify the molecular structure of deeper microplastic. The spectral fingerprints are unique for each polymer type, allowing the precise differentiation between the compound. And lastly, the image paired with the spectra provide additional specificity by linking the visual morphology with the spectra data, enhancing the overall reliability of identification process. Move on to the improvement in Raman spectroscopy for microplastic analysis. As we know that even though Raman has some advantage over the Fourier transfer infrared, which is FTIR, there are some disadvantages might be occur during using Raman spectroscopy, which the main limitation are the spectra has interference due to fluorescence. So there are three ways to overcome the interference, which firstly we need to set up the laser and wavelength power. So when we use optimal wavelength, we can reduce the fluorescent interference by lowering the wavelength into the near infrared IR, so we can minimize the fluorescence from organic material. Next step is we use the phantom agent. What is phantom agent? Phantom agent is a mixture of hydrogen peroxide and air catalyst which can degrade the organic matter that interfere the spectra. So when we remove the interference, we can have a high intensity of spectra. Lastly, we can use the stimulated Raman scattering (SRS). SRS is to the photon technique that can achieve faster imaging and high sensitivity compared to conventional Raman spectroscopy. Indicates speed up the mapping of microplastic and have high resolution image. As a conclusion, Raman spectroscopy is a robust and reliable method for detecting microplastic in food. It is important for environmental and public health protection. This is the end of this video. Thank you for listening, and here are some reference for this research.